Hi guys, I hope you are chowing this paper. I really hope that on the first 6 videos you were chowing, and if you weren't chowing, it's fine, guys. This is not an exam room. You are free to ask. Just ask me. I'll definitely come to you. Okay. Question 7. Ne? We are given an equation of f of x. We are supposed to write down the asymptotes of f of x. Okay. This value over here tells us about the horizontal asymptote, and then this one tells us about our vertical asymptote. Okay, so for our horizontal asymptote, let me write HA. Y is equal to -1, and for my vertical asymptote, X is equal to -4. Whenever you write your asymptote for the vertical asymptote, the sign that was here, it always changes, always the time. Okay, second question, they want us to calculate the intercepts of the graph of f with the x's. Basically, they want us to find the x-intercept and the y-intercept. How can I do that? For my x-intercept, I know that I don't care what kind of a graph I'm dealing with. I know that y is always 0. Y is always 0. So all I need to do is to substitute 0 whenever I come across y and then solve x. That means I have 0 here, and I'll still have 2 over x plus 4 minus 1. Then whenever I take the 1 to the other side, I'll have a positive 1 is equal to 2 over x plus 4. Multiply every term by the LCD. X plus 4 is 2, then x is equal to -2. Alright, together. And for the y-intercept, I don't care what kind of a graph I'm dealing with. I know that x is always equal to 0 on the y-axis. So all I need to do is to just substitute 0 whenever I come across to x, and then solve for y. Basically, I'm looking for f of 0. This would give me 2 over 0 plus 4 minus 1. This is 1 over 2 minus 1, -1 over 2. So these are my x and y intercepts. So for x intercept, I'll write here, and then for y intercept, I'll also write there. X intercept, x was equal to -2, y intercept, y is equal to -0.5. And then 7.3, I'm instructed to draw the graph. Right? The graph has the horizontal asymptote at y is equal to -1. So this will be my horizontal asymptote, and then the other one is at x is equal to 4. Okay, since the value of a is positive there, it simply means that my graph will be on the first and third quadrant rather of my asymptotes. Basically, my graph will just look like this. One curve will be here, and the other one will be there. All together. Then all I need to do is to indicate that I have a -2 and a -0.5 there. Y is 0. X-axis. This one is -4 and -1. That's my sketch graph. Okay. And then now I'm supposed to write down the coordinates of the image of the x-intercept if it is reflected about the axis of symmetry. My x-intercept is this one. The axis of symmetry is this line. So if I'm reflecting this point along this line, simply means that my point should be somewhere here. All together. So how do I reflect along a straight line? All I need to do is to say, let's call this point A. Point A Okay, let me just make an example of reflecting any point on the line y is equal to negative x minus 5. Okay, we're reflecting along this line, negative x minus 5, right? So your final answer should be the image of A. You need to take this y value and change its sign, negative y minus 5, and then take this x value, change its sign, negative x minus 5. This is how you get your reflected point, right? So in our case, we had negative 2 and 0, which would become negative 0 is just 0 minus 5, and then we also have negative 2 minus 5, and then the final answer will just be negative 5 and negative 3. So this will be my final answer over here, negative 5 and negative 3. I can see that negative 5 is right here and negative 3 it is below negative 1. So those are the coordinates of my of the image of the x-intercept. Okay, now I'm supposed to write down the range of y is equal to negative f of x. The range of y is equal to negative f of x. The range of y is equal to f of x. Okay, y is equal to negative f of x. This is simply y is equal to 2 over x plus 4 minus 1, and then the negative sign will affect inside the bracket, and then this will be a plus. So my range, I'll simply say y is an element of real numbers, but y cannot be equal to 1. Are we together? Whenever you write your range for your hyperbola, y can be anything, but y cannot be the asymptote. Are you together? That's how you get your range. Or the other way you can write your range, you can simply say y is an element of negative infinity to 1 and 1 to positive infinity. It's up to you. Okay. So you simply said y is an element of real numbers, but y cannot be equal to 1. Now we are supposed to describe the transformation that happened on f of x for us to obtain the graph of g. Okay, we can see that there in f of x, this guy was positive, but now it's negative, and then the two was also positive, but now it's negative. So here I can only assume that for them to have a graph of g, they just reflected along the y-axis, right? Whenever you reflect along the y-axis, you just change the sign of x. Whenever we do that, we'll have 2 over negative x minus 4. There's still a negative 1 there. I can take out a common factor there at the bottom. I'll have 2. There's minus x. No, remember that there's a plus 4 there from the original equation. So whenever I take out a negative sign, I'll be left with negative here, and I still have my negative 1. If I'm dividing if I'm dividing a positive number with a negative number, it simply means that the entire number will be negative. So I'll simply write negative 2 over x minus 4 minus 1. So what happened here, for us to get this type of equation that looks as theirs, we only reflected the graph of f on the y-axis. Are you together? So whenever you reflect on the y-axis, please remember that you always change the sign of x. So f was reflected on the y-axis. F was reflected on the y-axis. That's how, guys, we could have dealt with question 7. And I really hope that, guys, the videos are helping you out. Please stay tuned and wait for more. Thank you.